A very good evening to all of you. I welcome you all in this freshman course in Mathematics for Natural Science. This video is about an introduction to propositional logic. The contents of this video are sentence, types of sentences, proposition with examples and truth table. So let's start with sentence. A sentence is nothing but a basic unit of language that expresses a complete thought by following the basic rules of grammar. For example, I like mathematics in all subjects. Today I'll join you. Exams are from the next month. Would you like to have a coffee with me? How beautiful she is. Get out from my class. I think we should prepare for our mid-exams. She is afraid of dogs. May I know your name, please? My grandmother used to tell me a story every night. These all are sentences, and we can categorize all these sentences into four: the declarative sentence, imperative sentence, exclamative sentence, and interrogative sentence. Declarative sentences are nothing but a direct statement. For example, I am 18 years old. He had an accident when he was young. She lost her business in the COVID-19 pandemic. Mathematics is an interesting subject. Newton has given 3 laws of motion. So declarative sentence means a direct statement, while imperative sentence contains command, request, invitation, suggestion, warning, or instruction. For example, don't go there. Stop laughing. Let's go outside for dinner. It gives me immense pleasure to invite you to attend my marriage ceremony. Please finish your work by 4 o'clock. These all are imperative sentences. Exclamative sentence expresses strong emotions and ends with an exclamation mark. How beautiful you are. Happy birthday, Abraham. Congratulations, you have qualified this exam. Wow, you are looking damn cool. The next is interrogative sentence. It is a direct question and ends with a question mark. For example, what is your name? What are you doing here? Why don't you join computer classes? When will we meet again? Where are you from? Now come to the proposition. Propositions are a special category of declarative sentences. It is a very clear statement having only true or false value with no ambiguity. True means universally true and false means universally false. It may have true or false value but not both. So all propositions are statements, but all statements are not propositions. For example, Abraham is a rich person. Here the word rich is ambiguous, so this is a statement but not a proposition. Let's take another example. Addis Ababa is the capital of Ethiopia. It is a true statement and hence a proposition. 27 is an even integer. It is a false statement and hence a proposition. So propositions are either true or false but not both. If a sentence contains the following, it cannot be a proposition. If a sentence contains request, order, suggestion, opinion, exclamation, question, variable time like today, tomorrow, yesterday, pronoun I, you, he, she, it, etc., or any ambiguity. So a proposition must be free from all these. For example, please give me a glass of water. This is a request, so it cannot be a proposition. Get out from here. This is an order, so cannot be a proposition. What a beautiful day. This is an exclamatory sentence and hence cannot be a proposition. Tomorrow is a holiday. Here tomorrow is a variable time. This is not a proposition. He is a scientist. Here this sentence is not clear. Who is he? If I say Albert Einstein is a scientist, then it is a proposition. But here the meaning of sentence is not clear, hence it is not a proposition. Similarly, the color of her eyes is grey is not a proposition. I think he should go there. This is an opinion and hence not a proposition. Samia is beautiful. This is ambiguous sentence and hence not a proposition. Now, how to write a truth value of a proposition? If a proposition is true, we denote it by capital T, means true, and if it is false, we denote it by capital F, means false. Mathematically, a true proposition is denoted by 1 and false proposition is denoted by 0. Let us consider 5 propositions P, Q, R, S and T. P is natural numbers are finite, Q all integers are real numbers, R all squares are rectangles, S all odd numbers are prime numbers, and T Jimma is the capital city of Ethiopia. As we can see here, the proposition P is false because natural numbers are infinite. Proposition Q is true, all integers are real numbers. Proposition R is also true, all squares are rectangles. Proposition S is also false, all odd numbers are prime numbers. We can take here one example. 9 is an odd number but not a prime number. Hence, S is a false proposition. Jimma is the capital city of Ethiopia is also a false proposition because the capital city of Ethiopia is Addis Ababa. So in table form, we will write for proposition P, we will write capital F in front of it because proposition P is false and its mathematical value is 0. Q and R are true propositions, so we will write T in front of Q and R and their mathematical value is 1. Similarly, S and T are false, so their mathematical value is 0. Now, possible combinations of propositions. If we have two propositions P and Q, then the possible combinations are 4. Either both P and Q are true, P is true but Q is false, or P is false, Q is true, or both are false. If we have 3 propositions P, Q and R, then there will be 8 possible combinations. Either P, Q and R all are true, or P and Q are true, R is false, P and R are true, Q is false, P true, Q and R are false, P is false, Q and R are true, P and R are false but Q is true, P and Q false, R true, and all are false. If we have n propositions P1, P2 up to Pn, then the possible combinations will be 2 raised to power n. So it was about an introduction to propositional logic. Thanks for watching the video.